Today I'm going to be talking about the Pythagorean theorem, c squared equals a squared plus b squared. This is just an illustration of the concept into the size of the right angle triangle, just being demonstrated in terms of the areas of these squares to the corresponding sides. And this is a bust of Pythagoras of Samos, better known as just Pythagoras, and he was a Greek mathematician who came up with this relationship in right angle triangles, c squared equals a squared plus b squared. This is the Pythagorean theorem, and we apply it to several different it has several different mathematical applications. I have some problems for you guys to try out. This is a right angle triangle, obviously, we can tell. And it says find x in the following. So we just have the formula, c squared equals to a squared plus b squared. And then c squared being the hypotenuse. I should have mentioned that. C squared being the hypotenuse, we go x squared, subbing it in, just putting x's where you see c's, and you just see c here once, and you go a, which is 3 here, equals 3 squared plus b squared, which is 4 here, so 4 squared. This equals to x squared equals to 9 plus 16, and that gives us x equaling to 25. Now you square root both sides, so the square root of x squared, that just undoes the root, just undoes the squared, so that becomes x, and the square root of 25, this is the principal root, that becomes x equaling to 5. That's a bad one. 5. There we go. And we're done for that one, at least. Another one. And now we have find x again. So the formula, the general Pythagorean theorem. So that's c squared equals a squared plus b squared. Now subbing in the values. Subbing in just means just putting them in place of there. X squared equals to 12 squared plus 5 squared. That becomes x squared equaling to 144 plus 25. You just plug them into the calculator. And then x squared equals to 169. You square root both sides. Square root of x squared, square root of 169. This becomes x, simplifies that to be x equals to 13. Now notice, the x's for these two problems. Here x was 5 and x here was 13. These neat triangles with whole number sides are called Pythagorean triads. Pythagorean triads. And these triads have whole number values. They don't have a surd, so not because 169 is a perfect square, and then its square root would be 13, which is a whole number. So therefore this triangle would be these numbers would be a Pythagorean triad. Another one. Okay, again the general formula, c squared equals to a squared plus b squared. Oops, that's a bad plus sign. Okay, we just sub in the values. So x squared, pardon me, plus 14 squared plus 12 squared, plugging them into a calculator. 196, x squared equals 196 plus 144. Now x squared equals to 340. Notice this is not a perfect square, so if you square root this, you probably won't get a whole number. Square rooting both sides. Square root of x squared equals to square root of 340. Extend the radical. Sorry about that. Okay. And x is equal to let me plug that into my calculator. Approximately, in that case, equal to 18.44 to 2 decimal places. Notice this was not a whole number because this is not a triad. This is not a Pythagorean triad. Pardon my bad handwriting. Let me redo that. Pythagorean triad. So this is not a Pythagorean triad. Okay, and that's about it for this video. Thanks for watching. Hope that helps.